Okay, welcome back. And today we're going to continue on. We're going to now get into quadratic functions. And so with quadratic functions, we're going to start with the definition, of course. So in this, the definition of a quadratic function is a polynomial function. It is a polynomial function as we saw in the last video. So a quadratic function has the form of this. So f of x is equal to ax squared. So there's the degree, has the second degree. Ax squared plus bx plus c, where a, b, and c are complex numbers. Again, complex numbers. Okay? And a cannot be 0. Okay? Because if a is 0, well then we don't have a quadratic function anymore. We have a linear function. Okay? So a cannot be 0 for this to be a quadratic function. Okay, now b and c can be 0, right? Because remember, if b and c are 0, we get the basic function, or well, almost close. If a is 1, right? So if a is 1 and b and c are 0, we get our basic function x squared, our squaring function. Okay? Now, all quadratic functions look like parabolas. They are parabolas, right? So we know how parabolas look. So if we take the basic function y equals x squared, it's a parabola. Again, remember that the parabola it starts at the origin, opens upward, and it has a domain of all real numbers, right? And it has a range of 0 to positive infinity. Okay? It's continuous everywhere, right? So again, remember the characteristics. So, but one of the things I'm going to add is a new thing. One of the characteristics we haven't talked about regarding quadratics that we're now going to introduce is the axis of symmetry. So the axis of symmetry is the axis that splits the parabola in half. Okay? So in this case here, the axis of symmetry is right along the y-axis. So x equal to 0. Okay? So the axis of symmetry, right? So the axis of symmetry in this case is x equal to 0. Okay, so it's the vertical line at x equals 0, or in other words, the y-axis. Okay, so again, any parabola will have an axis of symmetry, and it's the line that will cut it in half. Okay, now one of the other features that I'm going to introduce now is what's called the vertex. Now the vertex is the minimum or maximum point of the quadratic function. Okay, so if you're looking at the graph of the quadratic function, it's the minimum or maximum point in the graph. So in this case here, for x squared, the minimum point is at the origin. So the vertex, in this case, is 0, 0. Now notice that the axis of symmetry goes through the vertex. That is always the case. That is another feature of the quadratic function, or the graph of a quadratic function or a parabola, is that the axis of symmetry always goes through the vertex of the parabola. Okay, so that means it gives us something, a reference point to find. We can use the axis of symmetry to find the vertex, or we can use the vertex to find or give us the axis of symmetry. Okay? Now, again, the parabola could open upwards or downwards. If it's open upwards, it's the minimum point. If it opens downward, then the vertex becomes a maximum point. Okay? And so we'll discuss more of that in later videos. But that's it. So that's the definition of a quadratic function and the axis of symmetry and vertex of the graph. Okay? Have a great day.